British Columbia is a province of trees, a land of endless forests, stretching in a living mantle from the deep fjords of the Pacific coastline 500 miles eastward to the crest of the Rockies, and from the international boundary 800 miles northward over mountains, plateau, muskeg, and parkland to the borders of the Yukon Territory. British Columbia has never been an easy country for the traveler to negotiate. His pathway has been restricted, hemmed in, and channeled by the ruggedness of a mountainous terrain. Along the coast, native cultures were based upon the sea. While the inhabitants turned the products of the dark forests to their use, they lived by and from the sea, and on its surface traveled freely. In the vast interior regions, the native peoples clung to the waterways, living by the lakes and along the river courses. They too traveled by canoe. When the waters proved too turbulent for their frail craft, they made their way on foot along the river's edge. The first white explorers to penetrate the mountain barriers from the east followed the waterways, establishing trading posts from the Peace River southward to the mouth of the Columbia. Other venturesome men had explored the Pacific seacoast. Traders, drawn by the lure of rare furs and safe anchorages, soon followed. It was not long before these men realized the value of the tall stands of Douglas fir crowding down to the shoreline. This was the start of the forest industry in that vast land that was to become British Columbia. Soon, crude sawmills were in operation, and teams of slow-plodding oxen were dragging giant saw logs to tidewater and the export markets of the world. The gold rush years of 1858 and 1859 saw hordes of miners bound for the Fraser River bars and placer gold camps of the Caribou. The famed Caribou Wagon Road was built from Yale to Barkerville. For the first time, British Columbia had an overland route from the coast to the interior, not wholly dependent on water routes. Then, with the opening up of other mining camps and the widening search for mineral wealth, the age of steamboating began. Shallow draft paddle wheelers pushed up navigable rivers, a form of transportation that was to last well into the mid-20th century on the Kootenai and Arrow Lakes. Then, in the 1880s, came the railway builders. Thousands of men toiled from the west, through the Fraser and Thompson River canyons, to meet with others building from eastern Canada on the summit of Eagle Pass. The steel rails of the Canadian Pacific Railway spanned the province and the nation from east to west. With the opening of this overland transportation route across the mountain ranges, man had taken a major step away from dependence on the ancient waterways. Meanwhile, the coastal loggers had been hard at work harvesting timber that lay close to tidewater mills. But this was not to last. As the forest industry approached the turn of the century, logging operations were gradually moving farther and farther back from the water's edge. There was still plenty of big timber, but now it was beyond the power of horses and oxen to move it down from the hills. Thus began the era of steam power, the era of donkey engines and logging railroads in the coastal forests. Steam opened up the forests, 10, 20, and even 50 miles back from tidewater. Steam power yarded logs out of the bush, loaded them on flat cars, hauled them to the booming grounds. Steam tugs towed rafts of fir logs to the mills. Now steam, in its turn, has given way to diesel power. Today, diesel trucks can operate at higher speeds, handle steeper hills, and navigate much rougher terrain than the steam trains of bygone years. They have opened a new era in logging both on the coast and in the interior of the province. Diesels power the trucks, and diesels power machinery to build the logging roads. Bulldozers and logging trucks have proved to be the twin keys to economic development of vast areas of timberland. The past 25 years have seen amazing changes in transportation in British Columbia. New highways have opened up inaccessible areas, particularly in the central and northern regions. The Pacific Great Eastern Railway now provides a north-south link between the Peace River country and the Port of Vancouver. Joining the transcontinental rail lines, it traverses some of the finest agricultural and forest lands in the province. These rail and highway routes constitute the framework of a province-wide transportation system that eventually will provide access to all of British Columbia's far-flung forestry resource. The Forest Service of the Department of Lands, Forests and Water Resources is responsible for the public management of the province's forest lands for the greatest benefit of the general public. Now, let us examine the resource itself. Forests cover more than 60% of the land area of British Columbia. Here is a natural asset whose value cannot be measured in dollars and cents. The living forest is one of nature's greatest gifts. This endless mantle of trees serves us in many ways. It is a reservoir for vital water supplies, retaining moisture from winter snow and summer rainfall, slowly releasing it down to streams and rivers. Without this control, water would rush unchecked down to the river valleys and on to the ocean. Erosion would remove topsoil, destroy the forests themselves, silt up riverbeds and reservoirs, and do tremendous harm to the fisheries, agricultural, and hydroelectric energy resources of the province. In BC, more than 7 million acres of timberland has been reserved for watershed protection. The forest also provides grazing land for agriculture. Wildlife is dependent on the forest. Big game animals, fur bearers, birds, and all the creatures of the wild find food and cover in the forest or along the forest's edge. Fisheries, wildlife, and forest lands play an important part in providing recreational facilities for residents of the province and visitors alike, a role which is bound to increase in value with the passing years. To maintain the forest to serve these varied uses, it must be properly managed for the greatest benefit of the forest itself. Today, the concept of forestry management is based on sustaining forests forever. Here is a resource which will regenerate itself. This forest cover is the result of uncounted cycles of growth following the retreat of the last ice age. For more than 10,000 years, trees have grown, died, and grown again. For generations, these wilderness forests have been ravaged by fire, disease, insects, wind, and storm. There are mature forests, new forests, fast-growing forests, and old decadent stands, decaying faster than they grow. The long-range goal of the British Columbia Forest Service is to bring all these varying forest stands under scientific management on a sustained yield basis, so that in time the whole of the province's timberlands will become a great tree farm. In such vast, undeveloped areas as still exist in British Columbia, the problem of easy access is still much the same as has faced the traveler since man first ventured into this wild land. Along the coastline and on the many lakes and navigable rivers, waterways still provide the easiest travel. Horses and pack trains are still used to penetrate beyond the range of boats and roads. And men must still travel afoot. Float planes have opened new vistas with transportation on the highways of the sky. Helicopters can land small parties of men in remote and rugged places. But with the Forest Service needs men and equipment on the ground, the only practical method is by road. Fire is the enemy of the living forest, when summer heat and mountainous terrain breed towering thunderheads. Lightning strikes in the most inaccessible places, and in many places in a short space of time. Air reconnaissance patrols, in conjunction with a well-planned system of fire lookouts, detect blazes before they have a chance to spread. Fixed-wing aircraft land men and light equipment on nearby lakes or rivers. Helicopters bring small suppression crews close to an outbreak. Aerial tankers drop chemical mud to reduce the intensity of a fire. But if a blaze gains headway, then it takes equipment and men on the ground to contain and eventually put out a major forest fire. The integrated forest companies assume the responsibility for protection on their tree farm licenses, presently covering 7 million acres of productive forest land, mostly in the coastal area. They are responsible for construction and maintenance of their own system of forest protection roads. They also build their haul roads to bring logs out of the woods. These are industrial roads whose prime purpose is forest access, and other use is often restricted for the safety of the motoring public. But after they've served their primary function of extracting merchantable timber from remote areas, many roads have become a part of the expanding public highway network. In addition to these tree farm licenses shown here in red, there are management areas with which the Forest Service is more intimately involved. The public sustained yield units shown in yellow. To date, 76 of these have been established. Administration and management of these units is the responsibility of the Forest Service. Here, the smaller independent forest operator can benefit from sustained yield management without the heavy capital investment of the tree farm licensee. The Forest Service builds roads for timber extraction, protection, and reforestation within these units. The program of constructing forest roads for the harvest of merchantable timber is an important economic factor in the successful operation of the public sustained yield units. These are no ordinary backcountry roads. Most of them are built to carry loads in excess of those the major highways will support. Forest roads open up new areas for cutting, assist the independent logger in extracting timber, and stabilize the economy in many smaller communities whose economic welfare depends upon the payrolls of the forest industry. The first step in building any road is to decide where it will start and where it is to end. In the case of the forest development roads, there's no doubt why they are built. The answer is simple. There is timber to be harvested, land to be brought into sustained yield. The specifications for a development road are tailored to the timber resource it will open up. Areas with a low volume of merchantable timber will only need a single-lane, low-order alignment road. On the other hand, a vast tract of forest wealth will require construction of a double-lane, high-speed forest highway with excellent alignment, low gradients, and permanent drainage structures and river crossings. The volume and direction of the heavy traffic is known in advance, and the specifications can be determined to fit the exact needs. Here again, aircraft bridge time and distance. Vertical air photo coverage of a proposed route saves months of legwork on the ground. From the air photos, skilled interpreters can determine the topography, assess the road chance, and plan preliminary routes before field crews get on the ground. The survey of a forest road is basically the same as any other highway project in heavily timbered country. Road routes, established on air photos, are reconnoitered in the field and control points are established. The line is then traversed with chain, compass, and clinometer. From a plot of the traverse and its profile, the final center line is determined. A team made up of 2 or 3 men establishes this final center line in the field. Underbrush is cleared away, and the compassman and the chainman lay out the tangents and curves of the new road. Levels are taken to establish elevations and enable the profiles of the road to be plotted. Then cross sections are taken. Forest stands along the center line are crews to estimate clearing costs. Notes are made on soils and water courses that have to be crossed. Site plans are drawn for the bridges required. All these data are booked and then plotted in the field. Here is the basic information to be used in the final engineering cost. The first step in construction is to clear the right-of-way. Clearing is very expensive and can run as high as 40% of the total cost of the road. Road building is road building. The same machinery is found on every job, and it gets bigger and noisier with each passing year. Solid rock is no stranger to these construction crews, cutting their way along the high valleys and across steep mountainsides. Compressed air, rock drills, hard steel bits, high explosives, and the skills and knowledge of the hard rock powderman soon reduce it to usable rubble. There are two important factors that must be considered in the design of these roads. First, the compaction of the subgrade must be of the highest order. Materials found in the high valleys are not as suitable for construction as the gravel soils of the lower elevations. Axle loadings of logging trucks are higher than those allowed on public highways. And unlike the public highways, the direction of travel of all heavy loaded vehicles is known in advance. Thus, the uphill climbs can be engineered to lower gradients than the downhill stretches in the direction of loaded travel. These roads are built to withstand the punishment of heavy loads year after year. So are the bridges along the routes, permanent structures designed to specifications far in excess of normal highway traffic. The Forest Service has pioneered the use of laminated beam construction in its bridge design. A good example of this type of bridge construction is at the Slessie Creek crossing on the Chilliwack River Forest Road. The main span is supported by 4 glulam I-beam girders. The girders were brought into the site 2 at a time by tractor and steerable trailer and erected by 2 cranes of 20 and 25-ton capacity. A typical forest road is to be found near Prince George, one of the important centers of the forest industry in the interior. Here is the Willow Public Sustained Yield Unit, an area of 180,000 acres containing approximately 350 million cubic feet of merchantable timber. In 1954 and 1955, reconnaissance and survey established the feasibility of road access. Construction started in 1955. The Forest Service built 20 miles of this road, and an additional 10 miles were built by contract, with the construction program completed by 1958. And now, today, numerous small operators harvest timber on this road system. The Forest Service builds the main haul roads, and the operators construct secondary roads. Construction of the Willow River Forest Road required major river crossings and the building of 3 permanent glue laminated type bridges. This road has also provided access to private timber holdings, which are now being harvested. But not all forest roads can follow the orderly pattern of survey and construction. Sometimes an emergency arises. In the early 60s, a severe storm in the extreme southeast corner of the province caused extensive damage to timber stands on the Flathead River, south of Fernie. Within 2 months, a reconnaissance and survey was carried out to locate a road to the blowdown area, to harvest the timber before it could suffer damage by fire and insects. This emergency project resulted in the building of a road into the area and construction of a 214-foot bridge across the Flathead River. The road was quickly finished and salvage of the timber got underway. 500 miles to the west is found the first forest road to be built on Vancouver Island, from Port Hardy to Cairns Lake and Nawitty Lake, and some 100 million cubic feet of merchantable timber in the Cape Scott PSYU. This road is now a major step in communication in northern Vancouver Island. Preliminary investigations were initiated late in the 50s, and surveys soon followed. Under Stage 1 in the building plan, 26 miles of road were constructed. The program required the erection of 5 permanent pressure creosoted bridges. Now saw logs are moving down out of the forest to the tidewater booming grounds at Port Hardy. Their ultimate destination, the forest products mills in the Vancouver area. As an added bonus, Rayonier of Canada built a 2.5 mile link from their Holberg road system to connect Port Hardy to Holberg and Winter Harbor. This is but one example of how a little-known road-building program is gradually opening up remote areas of the province. A program that will have a profound effect on the future of British Columbia. Since this program started, the Forest Service has built more than 1,000 miles of forest roads, run over 2,100 miles of location surveys, and carried out approximately 4,500 miles of preliminary reconnaissance. During the same period, emphasis on logging has shifted from the coastal areas to the forests of the interior. Pulp and forest product mills already built, under construction, or on the drawing boards, will create still greater demands on the resource. British Columbia's future is dependent upon its resources. Forest highways will continue to be a vital method of reaching and developing these untapped resources for the greatest benefit of the people.